Hello, everyone, again. Let's go to part C of the final exam review. Let's start out with chapter 14 content from, like I said, previous book. We just label it chapter 14. Here's problem number 1 over there and problem number 2 over there, and we're going to solve for both. Obviously, when you're doing this with graphing calculators, there are different graphing calculators out there that can solve systems of equations in various number of unknowns. Different graphing calculators out there, different computer programs out there, different computer systems that can do this. So for our purposes right now, let's kind of do it old school and get these answers and kind of take it from there. Again, we're in part C, Tech Math 1, final exam review, part C as we said. So let's go over here, and I would take, in this whole process, I'll take this second equation and kind of use it as a battering ram to get rid of the x's. There's just a regular x right here, which is the same as just 1x. And if I multiply by -2 all the way across, I'll have a -2x over there that I can add with this. So if I multiply by -2 all the way across, you get a -2x here, you add it with this 2x, it's out of there, and now you just got you got an equation with 2 unknowns. If you multiply the same equation later on by -3, all the way across and add it to this one, you'll get rid of that x over there, and then you have 2 equations and 2 unknowns. And then from there, you can work to get a solution to what's going on there. So with that in mind, let's see what we can do. If I were to take this equation right here and multiply it by -2 all the way across, I would get -2x plus -4y plus -14z equals -20. I will add it to the top equation, to the very, very top equation, which is 2x plus 5y plus 8z equals 11. Let's see what happens. -2x and +2x, you engineered it to be 0, and it is. This and this is -3y. This and this is -6z. And this is -9. Pretty interesting. Okay, we can leave that as is. Let's take, a lot you can do here. I mean, you can multiply by -1 on each side and get 3y plus 6z equals 9. That might be a little easier to look at. Something to keep in mind. Let's see what happens with the other one. Let's take this one right here again and multiply it by -3 all the way across. We initially started the process by multiplying this middle equation by -2 all the way across. That was the initial way we did it. We initially just took this, multiplied it by -2 all the way across, and then got that, and we added it on to the top equation. And we got this, which can also be written like that. Let's take this one again, the middle equation, and this time let's multiply it by -3 all the way across. Okay. We got it looking like that. And let's add that to this one right here. (3x plus 6y plus 12z equals 15. Okay. So there's a lot here. I mean, it's hard to keep track on what's what, but okay. So we're looking at this. Let's add these together. -3x and 3x is 0. -12y and +6y is -6y. -21 and 12z is -9z. And -30 and 15 is -15. Okay. So we've got this, and we've got this. A lot of ways you can go here. I'll tell you what, since we got these two, we're here. We got this. We got this. These can be manipulated. You could multiply by a -1 on each side of this equation. Multiply by a -1 on each side of this equation, and you got 6y plus 9z equals 15. Multiply by a -1 on this side of the equation, you got 3y plus 6z equals 9. A little easier to look at, I guess you could say. Let's do so. Let's multiply this one by -1 on each side, and you got this. Let's multiply this by -1 on each side of the equation. Sounds good. I mean, there's a lot you can do here, I guess. You could pull a 3, you could factor a 3 out of each of these. This guy right here could be 3 times the quantity y plus 2z. 9 is 3 times 3. Pull a 3 out of here, 3 times 2y plus 3z. Pull a 3 out of here. Now, I don't know that you needed to actually do all that, but okay, what the heck, we did. You've got this. You've got this. Take the top one here, divide by 3 on each side, and you got y plus 2z. Divide by 3 on each side, you got y plus 2z equals 3. Divide by 3 on each side here. So we divided by 3 on each side over here for the top one, and we got this. Divide by 3 on each side for this one, and we got this. You know, I guess it's maybe a little easier to look at things when they're positive numbers and when the numbers aren't that big. So we're looking at a situation looking something like this. Sure, let's just go down the line and make this thing work. Let's make it happen. We got y plus 2z equals 3. We got 2y plus 3z equals 5. So let's see what we got here. Erase a few things here, guys. It's hard to know what you want to erase sometimes. All right, so we got, this is 5y right here, you guys. This is 8. So that's kind of the way the originals are looking. We got this. Let's see what we can do. Let's take this top equation right here and multiply by -2 on each side, and then add the two equations. Top equation multiplied by -2. Top equation multiplied by -2 gets you this. Bottom equation, leave it as is, and just add the two equations. This and this, nothing. This and this, this and this, -1. Divide by -1 on each side. Z equals 1. That's a lot of work to get z equals 1, but we got it. We're going to find x, we're going to find y, we're going to find z. We just found z equals 1. If z equals 1, we can put z equals 1 into either one of these two equations to get y. And we just work our way backwards. Again, we could do this with determinants. We could do this a number of ways. Graphing calculator. Depending on how dexterous we are with it, there's a lot of things can be done. Let's go to this one. Y plus 2z equals 3. Okay. Y plus 2, you know, that's the top one right here. Y plus 2z equals 3. Z equals 1. y, that's 2, that's 3. Subtract 2 on each side. Y equals 1. That's interesting. Now to find x, we're going to plug in to one of, so let's see what we have here, guys. Let me try to find here. Yeah, absolutely. Yeah, looking pretty good, guys. We got y equals 1, we got z equals 1. We can go to any one of the three originals and get there. What the heck? This one looks pretty easy to look at. I mean, the 1x plus 4y. But any one of those three is valid to use. Anything that's associated with the original system is valid. One of these three is valid. 1 times x is just x. 4y is 4y. 7z is 7z. And 10 is 10. 10 is 10. Don't know what x is. I'm told that y is equal to 1. I'm told that z is equal to 1. And this is 10. 4 times 1 is 4. 4 times 1 is 4. 7 times 1 is 7. Equals 10. 4 and 7 is 11. X plus 11. X plus 11 is equal to 10. Add a negative 11 on each side. X equals negative 1. And there it is. Always a number of ways to go. Always a number of ways to go. Here are the options. But this works, and it's certainly true. At the end of the day, let's get this stuff right, you guys. Let's make sure we can do it and get it right. Because there are places that you do get asked questions and you won't be allowed to use a graphing calculator. Certainly in the tech math class that's being taught, you can use it. Other classes you cannot. So it's just good to know a myriad of ways to be able to do stuff and get the right answer. Okay. We have what we have, guys. We're doing pretty good. All right, now, like I said, some things don't always fit. Here's the answer for number 1. Sometimes you can't always rely on the recipes and always be stuck with that. We could have solved that last system of equations, 3 equations and 3 unknowns. We could have solved it using the determinant method. We did it using the elimination method, but we could have solved using the determinant method or other means that are at our disposal with graphing calculators. Same thing here. It doesn't matter what order you're putting these letters in, but once you put a particular equation in order with the 3 letters, in this case up behind me, H, K, and P, if that's the order, let's say, H, K, and P, the first column has to have all H's. The second column has to have all K's. And the third column has to have all P's. Doesn't matter. You can have all P's in the first column, all H's, all P's in the first column, all H's in the second column, and all K's in the last column. Doesn't matter. But the same exact letters have to be in any given column, whatever those letters may happen to be. One of the letters is H. They'll all have H in that column. Second column, is there a K? Oh, all of them have K in that column. Is there a P in the third column? All have P in that column. So you have to set them up in that way. Well, perhaps there's a way to get around this that's maybe pretty reasonable. Tell you what, this H all by itself is kind of neat. Let me add a 3P on each side and see what happens. You end up getting H is equal to 3P plus 3. For the record, I'd like to hold on to that. I'd like to say, okay, you know what? I think that's all right. H equals 3P plus 3. If that's the case with what just happened here, And again, what we're talking about is the original is just these guys, right? I mean, it was just this. You know, and you got this, and you got this, and you got this. All right, well, I took the third one, and I did some stuff to it. I took the third one here, and I did some things to that equation, and I, got that. Tell you what I'm going to do. Let me work with these two equations because this one doesn't have an h in it, and this one's about to not have an h in it. If I said wherever I see an h, I'm going to put 3p plus 3. So I'm going to take that second equation, and I'm going to go 2h plus 2k minus p equals 9. I'm going to say h is equal to 3p plus 3. 2k is 2k. Minus p is minus p, and you got 9. Wait a minute, what's going on here? Distribute that 2. Minus p equals 9. Minus p is minus 1p. Minus 1p is plus a negative 1p. What is 6p? What is 6p and negative 1p? It's 5p. This is 2k. This is 6. And this is 9. Why don't you subtract 6 on each side or add a negative 6 on each side? And you get 5p plus 2k. 9 minus 6 is 3. We just did something by substituting h equals 3p plus 3 into the h right here, and it's from this right here, I got that. These are mathematically identical equations. These are mathematically identical equations. They don't look the same, but they describe the same mathematical reality. Let me put it that way. I added a positive 3p on each side. And I got this. This and this are mathematically equivalent. I took h is equal to this, and I substituted, wherever I saw h, I put 3p plus 3, not in this one, because these are identical, but in this one, which is, this one's independent of this one. So from here, I got h equals this. Then I went over to the other one, and in place of h, I put 3p plus 3. Having done so, that whole thing came to what's over there, 5p plus 2k plus 3. Wait a minute. So if you're saying 5p plus 2k equals 3. True. And then you're going to say there's a 5k plus p equals negative 1. 5k plus p is the same as 5k plus p written in this order. P is 1 times p. I can go 5k plus p, or I can go 5k plus p, or p plus 5k. Guys, the big thing that just happened here is we have 2 equations and 2 unknowns. Those typically aren't that difficult to solve, if we're careful. Let's take this guy right here and multiply by negative 5 all the way across. And we end up getting negative 5p, negative 25k, and positive 5. That's this guy to here. We just brought this guy to this. Then take this guy and add it onto him. 5p, 2k, forgive me, I didn't multiply, I multiplied by negative 5. Multiply all of this all the way across, right? What am I saying? Actually, it did come out okay. Sometimes you don't need to correct things. Multiply by negative 5 all the way across. That's positive 5, negative 25. Yeah, it looks pretty good. Let's take this guy. Let's add them together. Negative 5p and 5p, you engineered it so it's 0. Add these two, you get negative 23. Negative 23k. You added this and this, 0. You were shooting for this thing to become a negative 5p by multiplying by negative 5 on each side of the equation, and you got this. Then when you got this, you added this onto that very top equation, and those cancel. The 2k, just bring that down to here. The 2k and the negative 25k is negative 23k, and the 3 and the 5 are 8. Well, divide by negative 23, yeah, these aren't exactly the ideal numbers to be looking at sometimes, but we are where we are, guys. We got k equals negative 8 over 23. Well, let's get as many of these as we can. They're not going to be that easy to look at, as you can pretty plainly see. Let's go over here. Let's go to one of these. I mean, it doesn't matter which one. Let's go with, after we solve it, let's go with 1p plus 5k equals negative 1. So 1p is just p plus 5k equals negative 1. 1p, which is just p plus 5k equals negative 1. They got the k there, I guess. Well, I don't know what p is. I'm going to find it pretty soon. I'm going to go 5 times k. 5 times k. Five times, now it's really 5 over 1, same thing. It's negative 40 over 23. Right? Forgive me, I didn't jump in the gun here. They're not equal to anything yet. We're just doing this. We got this equal right here. P plus negative 40 over 23 equals negative 1. Does everybody understand that negative 1 is the same as negative 23 divided by positive 23? Let's get a common denominator here, guys. If I add a positive 40 over 23. If I had a positive 40 over 23 on each side, now we got p equal to something. What's negative 23? What's negative 23 and positive 40? Yeah. P is 17 over 23. K is negative 8 over 23. Wow, I mean, I guess at this point, I guess H can help us out. This equation here, let's see. H would be equal to 23 in the numerator. 23 in the denominator seems to be the soup of the day, guys, so let's kind of watch out. 3 times P, and we said P would be equal to, P is 13 over 23. Plus 3. Well, we got to talk about 3. Is 3 the same as 3 over 1? Yeah. Is 3 over 1 times 23 over 23 still going to be 1? Yeah. 3 over 1 is 3. 3 times 23 is 69. 1 times 23 is 23. 69 over, yeah, that makes sense to me. 69 divided by 23 is 3. So let's kind of keep that in mind when we're doing this. See where we are here. H is H. 3 times, that's really 3 over 1. 3 times 17 is 51. It's 51 over 23. 3 is the same as 69 over 23. We're not talking about negative numbers here. No, so you got quite a lot of numbers here is what we got. H equals, you add them together, yeah, I mean, it's a rough one. 120 over 23. So a lot going on here. Let's talk about all of it, I guess. We can say that 51 onto 69 is the same as 51 onto 69 is going to be 120. Okay, so H, K, and P. Let's take some looks at this thing. I've got 120 over 23. I got negative 8 over 23. For that one. And for P, we got 17 over 23. Wow, okay. H, comma K, comma P, I'll put them in order, guys, is 120 over 23, which is 5 point something, negative 8 over 23, which is, a little more, negative 8 over 23, a little more than negative 0.33. Try and get some ballpark ideas here. This is 17 over 23. Absolutely. 120 over 23 is about 5 point something. Not too much more than 5, but it's more than 5. About, 5 point, a little more than 5.2 maybe. A little more than 5.2 for this. This right here, a little more negative than negative 0.33. So maybe negative 0.34 or something. So around negative 0.34, negative positive 5.21, negative 0.34. This right here, it's a good question. Let me see, get a ballpark idea here on this one. Between 0.6 and 0.7. Between 0.6 and 0.7, between negative 0.33 and negative 0.35, between, 0.15 and 5.25, something like that. Well, if those are the cases, let's actually speak their language. We take it to the nearest hundredth, I'm sorry, and we'll get there. We'll be there. So round to hundredths when necessary. Well, this time we didn't have to for number 1, but for this problem number 2, yeah, I think we obviously going to need to. Let's see what we have. 100 for H, 120 divided by 23. 5.217, 5.217, 5.22. How's that? For K, negative 8 divided by 23, negative 0.3478, negative 0.35, negative 0.35 on that one. 17 over 23, .739130. 0.739, the 9 brings the 3 up to a 4. And there we go. Let's make sure we're agreeing with them, guys. we're not agreeing, I got to look at it again, but I think I got a feeling we're going to be in agreement. But there's a lot going on, so I mean, you don't know that for sure either. Yeah, it looks pretty good. Looks pretty good. We've got, let's see what we got here, in fact. We have here is there, when you're rounding to the nearest hundredth, you get h equals 5.22. So h equals 5.22, k equals negative 0.35, p equals 0.74. So, not bad. Absolutely. Keep going. I mean, regarding some of this stuff, see what we can do. Let's go. They got chapter 3, which has got like Tech Math 2 type material. But like I said, it's a review test. I think if we know this stuff, guys, at the end of all of this, at the end of all these videos, if we know all this stuff, these are literally hundreds of problems that we're solving from start to finish. If we know these, we've got a pretty decent background in some basic algebra that can help us move on to a number of things. We get a real strong basic background. Make sure you're viewing these films, guys, for your edification. It's worth your time. If you're not entirely comfortable with what's going on there, then please be viewing these films. Let's go to the chapter 3, TM2, and then onward. Let's see what we can say. Give me 1 second, and we will start this up again. Just put it on pause right now. Okay, everyone, let's keep going. They want you to do a subtraction here. A number of ways to do it. They want it in order, from high order to low order. A lot of ways to go here. One way to do it is when you have subtraction like this, you can distribute the subtraction all the way across. You just take the minus here and get inside. It becomes minus 2y squared. Minus a minus becomes plus 5y. And minus 3 is just minus 3 or plus a negative 3. That's one way to do it. A little more complicated way to do it, maybe I shouldn't even go there. I mean, we talk more in the future when we do these. But generally, I mean, you can just put like a 1 right here, and then go plus a negative, and then go all the way across. Make everything in terms of addition. Right now, I guess I'm going to opt not to go there. I'm going to leave this as is. Minus 2y squared. Distribute the subtraction in a sense. Minus, and the reason for that is there's really a 1 right here. You're distributing the 1 is what you're doing. And then you get into the opposite of every item that's there. If you convert everything into addition, it's actually the easiest way to go. I'm sort of doing that here in a backhanded way. Subtract, bring the minus inside, you got this. Then go minus a minus, then you got this. Then you go minus the other one, you got this. Sounds good to me. Convert everybody into addition. This is not the only way to do it. Minus 2y squared is plus a negative 2y squared. I see the y squareds. I see the regular numbers. And I see something not similar to either of those. 3y squared and negative 2y squared is 1y squared. Good enough for me. The 5y, nothing's being done with it, so leave it alone, but mention it. What's negative 3 and positive 2? It's negative 1. You can stop right there. You can write this as 1y squared plus 5y minus 1, or 1y squared plus 5y plus a negative 1. Either way is fine, but it works. We got the answer that we need. So, see what else we can do here, guys. K is the same as 1k. Minus 1k is plus a negative 1k. The FOIL method is simply the distributive principle done twice. I'll take the 5h I'll take the 5h and distribute it here. Then I'll take the 2k and I'll distribute it to the same places separately. 5h times 4 is 20h. 5h times a negative 1k. 5h times a negative 1k is negative 5hk. 2k times 4k is 8k squared. 2k, for some reason, did I just write the wrong? No, that should have been an h. I'm sorry, guys. That's an h. Okay, let's start this. Let's start the whole thing over. I'm sorry about that. Didn't look right from the get-go. We'll figure it out. Let's try it again. We've got 5h. The k and the h can look alike. I guess if you write like I do, I guess anything can look alike. That's on me, my fault. We got the quantity 5h plus 2k and the quantity 4h. Did it again, didn't I? And the quantity 4h minus k. Minus k is minus 1k. Minus 1k is plus a negative 1k. All right, let's try it one more time. Let's take 5h and go over here and go over here. That's the distributive principle. Done once. Then you take this guy and do the distributive principle again with that item. And then you add the two. So what do we got here, guys? We got 5h times 4h. 5h times 4h is 20h squared. We got 5h times negative 1k. That's negative 5kh. 2k plus 2k times 4h is 8kh. And 2k times negative 1k is negative 2k squared. Okay, that makes more sense. If you take these, which are like terms, negative 5 apples and positive 8 apples is positive, negative 5 apples, or 5 apples taken away from 8 apples is 3 apples. You got that. You got this. And we have that. It's not looking too bad. Okay, guys. What they're saying here is factor completely. Can you factor this thing out? Well, it's kind of a rough one. I mean, 20 behaves in a pretty interesting manner. You've got a lot of potential tries at this. Only one of them is going to work, but there's numerous iterations to do this. We know that 1 times 20. We know that 1 times 20 is 20, 2 times 10 is 20, 4 times 5 is 20. Tell you what, that number in the middle is not that big. I'm going to take a 5h. I'm going to take 5 times 4 to get 20. I'm going to say 5h. I'm going to say 5h times 4h. 5h times 4h is 20h squared. I am going to look at it some more and then say, okay, wait a minute. What do you say 2 times 4 is 8 and 1 times 5 is 5? What's 8 minus 5? It's 3. I'll make this the minus part. I'll make this the plus part, and I'm done. And I'm actually done. It'll work. You grind it out. You can make the minus 1. You can make the minus 1 plus a negative 1. This is it. Let's confirm it. Let's get the outskirts. Let's get the outskirts of this thing. This and this, and let's see what the middle is. Okay. 5h times 4h is 20h squared.
2 times negative 1 is negative 2. 2 times 4h is 8h. Negative 1 times 5h is negative 5h. Negative 5h and positive 8h is 3h. You can grind it out in terms of doing the distributive principle twice, also known as the FOIL method. You're basically taking this item right here and distributing it. You're taking this item right here and distributing it throughout here. And then you're taking this other item and also distributing it through there. That's the same thing you can do here to test if that's actually true. Looks pretty good. Looks pretty good. Maybe I got a little more space here, guys. I can put maybe another item as well, since it came out pretty good that way. Let me see what we could say here regarding this one. So what we have here how do you want to do this? Well, tell you what I'm going to do. 5m is 5m. M plus s, I'm going to call it the quantity m plus s. You'll see why. Pull a 3 out of the top completely, and we got m plus s. This is 15 ms right here. The whole thing, m plus s, the whole quantity, m plus s, the whole quantity, m plus s, it's gone. 5 goes into 15 3 times. M goes into m once. Yeah, there's a lot of stuff going on here. The 3's do cancel. A lot going on here. What is this at the end of the day? What we have here, 1 times 1 times 1 times 1, well, not surprisingly, it's 1. 1, yeah, well, this is kind of neat. Oh, there's an S right here. I almost thought I was going to get another one down there. There's the S at the end of the day right here, guys. We've got 1 times 1 times 1 times S. There it is. Looking pretty good. Just confirm, let's just make sure we're on pace here to do this stuff okay. Let me kind of see here what I've done here, guys. I think did I jump to say, yeah, I jumped pretty far here. Well, I guess, guys, tell you what, time out. This thing is no lie. It does work. It's true. Let me leave it here. We just solved it. We'll do it again for the future. I didn't want to do that one just yet, but well, it's here. We did it. It was supposed to occur some other time. That's all right. Let it go. Let it go. We'll come right back to it. Let me see what I got right now that is valid. I can maybe start taking some of this stuff out of here. Because sometimes these numbers repeat. There's 1, 2, 3, and there's a 1, 2, 3, and there's another 1, 2, 3, and they're in different chapters here. So there's a lot of problems here, guys. A lot of fascinating problems that are going to help us out. We did do number 1 and number 2 here, and then I jumped to number 3 in chapter 4 and ended up doing this. And this from chapter 4. So let's leave it up there for now, I guess. Yeah, I actually did 3 and 4 from, well, okay, this is pretty fascinating stuff, guys. We did what we did. We don't need to do it again, but let me tell you where it came from. We are going to take these two, and they are going to get solved later, and they're going to be the exact same answer. This stuff is going to be, this right here is chapter 4, 3 and 4. Right. This is chapter 4, problems 3 and 4. There's 3. There's 4. Stay tuned. We'll come to this. I wasn't supposed to be getting to chapter 4 yet, but there it is. Keep that in mind. Let's stay with the Let's stay with chapter 3. This is also TM2, kind of more of a Tech Math 2 type problems. All right, so that's these guys right here, guys. 1 and 2 from chapter 3. Right, problems 1 and 2 from chapter 3. Let's see how that works out. Yeah, absolutely. Number one is y squared plus 5y minus 1. 2 is 28 squared, 3K, forgive me, 2 is 28 squared plus 3KH plus a negative 2K squared, or minus 2K squared. That's fine. That's 1 and 2 on this. Let's stay, like I said, this is chapter 4. Let's keep both of these as the chapter 4 stuff when we get there. So both of these are going that way. So, okay, I jumped the gun on those. We'll come right back to those. Let's finish the chapter 3 stuff. So for chapter 3 stuff, we got 1 and 2, and that's this. So for the chapter 3 stuff, let's go to number 3. So for chapter 3 stuff, for the stuff that's coming out here, let's go to number 3. Number 3 in the chapter 3 stuff is 3a minus 5b, that quantity squared. There's not a shortcut that you might think exists, depending on what shortcut you're thinking. You can't bring the square inside of each of these. You can only do that when there's a division or multiplication present. But when there's an addition or subtraction present, you can't do that. You got to write it out as 3a minus 5b, 3a minus 5b. I like to add. Minus 5b is plus a negative 5b. Minus 5b is plus a negative 5b. You go here. You go here. 3a times 3a is, well, let's see what we got. 3a times 3a, 9a squared. 3a times negative 5b, 3a times negative 5 is negative 15. The a and the b multiplied together give you this. Negative 5b times 3a. Now notice what we just did right here. We went 3a times 3a and got 9a squared. We went 3a, we kept going. 3a times 3a, 9a squared. 3a times negative 5b, we got 3 times negative 5 is negative 15. A times b is this. Then we went here. Let's do it again. Let's go 5b times 3a, or negative 5b rather. Important to know that. Negative 5b times 3a. Negative 5 times 3 is negative 15. b times a is ba, or ab. Not a big mystery there. Negative 5b times negative 5b, negative 5 times negative 5 is 5. Forgive me, negative 5 times negative 5 is positive 25, and this is what we got. Negative and negative is even more negative. Negative 15ab and negative 15ab is even a more negative answer. They don't cancel. If it's positive 15ab and negative 15ab, they'll cancel. But negative and negative is even more negative. We've discussed that. We said earlier, the negative 5b times the negative 5b, negative times negative is a positive answer. Negative 5 times negative 5 is 25, and we get to here. And that's the number 3 I should have done. That's the number 3 I should have done from chapter 3. So we got that one. Now we go to 4, and that's where these guys came in, chapter 4. Forgive me. No, we don't. We still have problem number 4 from chapter 3. So we got this right here. Let's just confirm this. This should not be a problem whatsoever, guys. 9a squared minus 30ab plus 25b squared. 9a squared minus 30ab plus 25b squared. 9a squared plus negative 30ab plus 25b squared. That's it. Let's go number 4 of this. So these are all, like I said, the 1 and 2 that I did earlier pertained to chapter 3, Tech Math 2. The 1 and 2 that I did earlier over here pertained to chapter 3, Tech Math 2. The 3 here pertains to chapter 3. Okay? So 1 and 2 pertained to chapter 3 that we just did here. 1 and 2 pertained to chapter 3. The 3 that we just did pertains to chapter 3. And now this 4 pertains to chapter 3. Then we're done. Then we're going to go to chapter 4. I already did 2 of them in chapter 4 accidentally, so we'll come back and do it again, I guess. They talk about long division. It's a very fascinating topic in its own right. There's a lot of things can be said. Let's at least just answer the questions that they're giving to us right now, and we'll kind of take it from there. They're saying the quantity 2x minus 3, I like to put it in parentheses. They may not, but I do. 2x minus 3 is that. And you got this, which is 6x squared minus x minus 13. You guys know I like to add. X is the same as 1x. This is plus a negative 1. This is plus a negative 13. The minus 3, 2x minus 3, is plus a negative 3. Okay, not too bad. You take the very lead term and you put it into the very lead term and see what happens. 2x goes into 6x squared. Well, 2 goes into 6 3 times. X goes into x squared x times. So 2x, so you take 6x squared and you're dividing it by 2x. That's 3, that's x. So you're going to get 3x. Two x goes into 6x squared 3x times. Then you take 3x and multiply all of this. And you end up getting 3x times 2x is 6x squared. 3x times negative 3 is negative 9. 3x, so let's see, do it again. 3x times 2x is 6x squared. 3x times negative 3 is negative 9x. You take this and you subtract it from this up here, this part of it. 6x squared minus 6x squared is 0. Minus a negative 9x is plus 9x. Plus 9x and negative 1x is 8x. Then you bring the negative 13 down. Go lead term. How many times does 2x go into 8x? 4. Multiply them across now, everything. 4 times 2x is 8x. 4 times negative 3 is negative 12. Minus across it. 8x minus 8x is 0. 8x minus a negative 12 is plus 12. Plus 12 and negative 13 is negative 1. It's a remainder of 1. Now, I don't know how these guys give the answers, guys. A couple ways I've okay, they gave them the way I'd like to give the answer, actually. When you get down to here and there's nothing else to bring down, you take this, and when you get down to here, there's nothing else to bring down, you take this, and you bring this underneath it. In other words, once you get down to here, there's nothing else that can bring down any further. Take the negative 1 and divide it by this. And it becomes plus a negative 1 over 2x plus a negative 3. There's your answer. Now, that can be written in a lot of ways. Let me try to write it the way they wrote it so that we not have any arguments here. The way I write it is this. I write 3x plus 4 plus a negative 1 over 2x plus a negative 3. That's my way of writing it. Not that I'm doing anything spectacular here or anything, but this is the way I write it. You write it like this, you'll get full credit. Don't worry. The way they're writing it, and there's absolutely nothing wrong with the way they're writing it, you can write it as 3x plus 4 minus 1 over, instead of 2x plus a negative 3, 2x minus 3. They write it like that. Either one is fine. Either one is fine. Either one is fine. This is called long division. This is from practice final exam. This is from the practice final exam, chapter 3. Just like 1 and 2 that were here just earlier were for chapter 3 practice, this one right here was also as such. So let's see, which one is that? Let me see. Forgive me. Just as you know, we had 1, 2, 3, 4. As we did 1 and 2 right here, that was for chapter 3. As we did 3 right here, that was for chapter 3, and we just did 4. Okay? So chapters 1, 2, 3, you actually got them for 1, 2, 3, 4. Forgive me. Chapter 3, you got problems 1, 2, 3, 4. Those were everything here. I accidentally jumped to chapter 4 and did problem 3 and 4 from chapter 4. That's not chapter 3. This one right here, like I said, we already did 1 and 2, and then we did 3. 1 and 2 we did here, then we did 3 here also, and this one right here is 4. All of those 1, 2, 3, 4 that we did right here on this side, on your left side, are for chapter 3. For chapter 4, we'll get to that in a second. So let's see here. Yeah, I don't, for the life of me, I guess I'll start with the new stuff. So that'll be it, guys. It's looking good. It's looking good. Leave the chapter 4 stuff for leave chapter 4 stuff, problems 3 and 4 for chapter 4. We're leaving it there. We're going to come back to it. Let's do chapter 4 right here. Now let's do chapter 4 right here and go all the way across. We'll get to 3 and 4 in a second. Let's do 1 and 2. So, number 1 and 2, let's figure out what they're talking about here. Should be pretty straightforward stuff. Then we'll get to number 5 as well. For chapter 4, here we go. Part of it, some of the review, factor completely, they're saying here, for 8d squared minus 8k squared. Pull an 8 out of here. d squared minus k squared. You guys remember the a squared minus b squared that we talked about some time ago? That's the quantity a minus b times the quantity a plus b. Use the same argument here. A is the d is the a, the k is the b. The quantity a squared minus b squared, a difference of two squares, a difference of two squares, a squared minus b squared reduces to the quantity, factors to the quantity, a minus b times the quantity a plus b. Well, this is the same kind of thing, guys. It's d minus k, d plus k. Doesn't matter which one you put first, just make sure you got them both. Well, this right here, if you got the 8 right there, the 8 stays as is, and you got d minus k, d plus k. And that's number 1. That's 1 from chapter 4. Chapter 4, TM2, Tech Math 2 kind of material, but it's in the review exam. Again, this is all on the 5th page, you guys, for this part C. This is all on the 5th page. When we get to the 6th and last page, that will be the part D that we're talking about. So I broke it up into 4 parts. The first part A had the first 2 pages. The first part A, had the first 2 pages that we were covering. The second part, part B, had the 2 pages after the first 2 pages. So that's what was covered there. And then the last 2 pages are going to be part C and part D respectively. So first 2 pages, part A, second 2 pages, part B. The page after that, page number 5, will be part C, and the last page, page number 6, will be part D. So pages 1 and 2 were part A. Pages 3 and 4, pages 1 and 2 are part A. So pages 1 and 2 are going to be part A material. Pages 3 and 4 are part B material. Page 5 is this stuff right now. This is all page 5, this is part C material, and then page 6 is going to be part D material. So, okay. Sorry, guys. I mean, so there's a lot of stuff here. There's literally at the end of these 8 worksheets, I don't know how many problems they come out to. I tend to think at least 200, maybe up to 300, maybe more. I mean, there's hundreds of problems. If you know these, you're going to be in good shape to do a lot of basic mathematics and a lot of basic algebra, and you're really on your toes to go to higher material if you want. You're really building a good foundation with these literally hundreds of problems that we're doing. Please take advantage of it. Please take advantage of it. That's that. 2, is saying factor completely, x squared plus 4x plus 3. Let's go. Let's get the outskirts. X times x, x squared. 1 times 3, that's 3. Is the middle stuff going to work? 1x is 1x. 3x is 3x, the smiley face thing. I think we're okay. If you do the FOIL, this is like a shortcut to it, but if you FOIL this out, do the distributive principle multiple times. If you multiply this out the way I've shown you how to multiply it out, you're going to be fine. You're going to get the right answer, and this is the answer. This is 2 from chapter 4. So 1 and 2 from chapter 4. 1 and 2 from chapter 4. 3, finally, guys, I'm sorry. 3 from chapter 4 is right here now. So you did 1 and 2 from chapter 4. Now you're going to do 3 from chapter 4. Then you're going to do 5 from chapter 4. Okay, we've already done this. You kick this around a little bit. You say, okay, 5h times 4h is 20h squared. 2 times negative 1 is negative 2. Does this work? Does 2 times 4h and, does 2 times 4h and 1 times 5h, is it going to work? 2 times 4h is 8h. Negative 1 times 5h is negative 5. 2 times 4h is positive 8. Positive 8 and negative 5, yeah, it's 3h. It's working. The 2 times negative 1, everybody works out. 5h times 4h, 20h squared. 2 times negative 1, negative 2. Positive 8h with the negative here, negative 5h, negative 5h and positive 8h right there. You got it. So that's that. So 1, 2, 3 from chapter 4. Over here we had the setup. We basically took this guy and made it a quantity. You distributed the 3 out of here. You distributed the 3 out of here and you got it down to there. So just for the heck of it, I know you already saw it. I'll try to make it not be too lengthy of a discussion. Let me do a spoiler alert. The answer is going to be this one. 1 over s. Let's just do it. This is 5m over the quantity m plus s. Pull a 3 out of here. This is 3 times the quantity m plus s. This is 15 ms. The 5 into the 15 3 times. The m into the m 1 time. This entire thing, m plus s, goes into m plus s 1 time. The 3 and the 3 cancel. Wow, there's not a whole lot left up there, you guys. 1 times 1 times 1 times 1 is 1. 1 times 1 times 1 times s is s. And that's where we're getting this. Okay? Those are problems 1, 2, 3, 4 from chapter 4. Earlier we had problems 1, 2, 3, 4 from chapter 3. We just finished those. Now we come back and we just tie this whole thing up. From chapter 4, this is 1, 2, 3, 4 from chapter 4. Let's do problem 5 from there. Problem 5 is a pretty classic type problem. Solve that proportion. 2 ratios are set equal to each other, so we call it a proportion, and we will take it from there. Okay, so let's take care of everything that we need to, guys. I think everything looks okay. So let's go for the 5 here. One, 2, 3, 4 from chapter 4. Now let's go 5 from chapter 4. And then we can move on a little bit from there. All right, guys. So again, I mean, there's much to be said. Let's keep saying it. They want you to solve an equation looking like this. Whenever in doubt, if there's a whole quantity by itself, there's nothing wrong with putting parentheses around it. In fact, it's almost a must sometimes. Do cross multiplication. Let's take this one, go up. X minus 1, to the x plus 3. Got it? The other one is x minus 1, x minus 2 rather, x plus 1. Yeah. So we did We did, cross multiplication this way, and cross multiplication this way, we got to here. Play the game. Let's go to the outskirts. X times x, x squared. Negative 1 times 3, negative 3. Here we go. Negative 1x and 3x. 3x and negative 1x. 3x and negative 1x. We've got x squared plus 2x minus 3. Outskirts, x squared. This one right here, minus 2. Let's do the smiley face thing here. You got negative 2x. You got 1x right here. See how that's going to play out. Okay, let's time out. Let me just, I said what I said. Let me just do that one more time, actually. As we're looking at this thing, you already know that it's going to be x squared's big that way. Minus 3 is here, plus a negative 3. In between all that, you got 3x, and over here you got negative 1x minus x, minus 1x or plus a negative 1x. That's going to be equal to this. Do all, the outskirts are this. The negative 2 is this. That's plus a negative 2. This is negative 2x. The other guy is 1x. Minus 2x is plus a negative 2. All right, 3x and negative 1x is 2x. This is x squared. Negative 2x and 1x, forgive me, negative 2x and 1x is, negative 1x. Let's solve the equation, guys. Well, let's subtract whatever we can subtract on each side, and maybe things fall apart. Subtract x squared. Subtract x squared on each side. 2x plus 3 equals whatever's going to happen here. So these are going to go. These are going to go. Equals negative 1x plus negative 2. This isn't bad. Now what? 2x plus 3 equals negative 1x plus negative 2. Let me add a positive 1x on each side. This is out of there. 3x plus 3 equals negative 2. Let me add a negative 3 on each side, or subtract 3. Be careful, though. Don't get careless. 3x equals negative 5. Divide by 3 on each side. X equals negative 1.6 repeating. X equals negative 1 2/3. X equals negative 5/3. It doesn't really matter. Just get it right. And that's 5. And for some reason, that doesn't make any sense. So what happened here? You got me on this one, guys. Let me see here. Something's up. Yeah, I'm staying with this, but I don't know if I need to stay with this. Let's, they're giving a different answer here. They're giving for number 5, they're saying 1/3. I know they thought this out really well, so I just don't want to go there. X plus 3 over x minus 2. Let's make sure I got the right problem on here, guys, if anything. We've got x plus 3, x minus 2, x plus 1 or x minus 1. Let's see what we got here. X plus 3, x minus 2. X plus 3, x minus 1. Right, let's see. Yeah, right. x plus 3, x plus 3, x minus 2, x plus 3, x minus 2, x plus 1, x minus 1. I don't buy what they're saying, but I would bet I'm wrong, so let's be careful. X plus 3 over x minus 2, x plus 1 over x minus 1. Cross multiply, you got this. Cross multiply the other one, you've got that. Let me sometimes explaining things makes me get it wrong. That's my fault. I can't walk and chew gum at the same time. Let's see if any of this is true. I'm getting, when I do it, just in my head real quick, this is x squared, this is negative 1x, positive 3x. That's a positive 2x. I might have gotten it wrong there. That's that. This right here is x squared, negative 2x and positive 1x is negative 1x. Time out. This is definitely where it's at. This is x squared. This x times x is x squared. Negative 1x and positive 3x. Negative 1x and positive 3x is 2x. Negative 1 times 3 is negative 3. That's it. That's where the mistake happened. Mistake's on me, guys. So, well, it happens. We didn't give the final answer on it, I guess you could say. See where this is going to go. This should give you the 1/3 we're talking about. Subtract x squared on each side. 2x plus negative 3 equals negative 1x plus negative 2. 2x plus negative 3. 2x plus negative 3 equals negative 1x plus negative 2. Add a positive 3 on each side. Negative 2 and positive 3 is 1. Add a positive 1x on each side. Two x and 1x is 3x. This is out of there. That's 1. Divide by 3 on each side. Yeah, it's good to check, I guess, right? Sometimes it's just easier to just do it on your own, think it out, and do it. You can still get it wrong. Explaining it, I guess, is one of the can be a little bit of a challenge. Walking and chewing gum, I guess, right? But there it is. At the end of the day, x equals 1/3. Sounds good. They want you to solve a few things, kind of Chapter 5 type stuff, Tech Math 2 type stuff as well. Chapter 5, Tech Math 2 type stuff, they got problems 1 through 6. Round decimal solutions to hundreds if we need to do so. Let's run through this somewhat quickly, but let's get through it. They were saying So 5 how's this going to play out? Well, solve these quadratic equations. Let's see what we can say. Number 1, they've got x squared minus 5x equals a negative 6. Add a positive 6 on each side. You get a 0 right here. You get 6 right here. You got 5x right here, and you got x squared right here. From here, factorization is probably, probably the best way to go, if you can do it. The way I'm looking at it is, when you do the factorization and always do all the verification that you need to verify, well, x times x is x squared. 2 times 3 is 6. But I need a negative in the middle, so I got to make that a negative 2, and I got to make that a negative 3. Is it true that x times x is x squared, and negative 2 times negative 3 is positive 6? Let's do the smiley face thing here. Is this negative 2x? Is this negative 3x? Negative 2x and negative 3x is negative 5x. It works just right. So you got this right here. You do the factorization. The only way the product of those two things can equal 0 is that if one of the factors or the other factor or both factors are equal to 0 simultaneously. They don't simultaneously have to equal 0. Just one of them has to equal 0. Just one of them has to equal 0. What would make x minus 2 equal to 0? X equals 2. What would make x minus 3 equal to 0? What would make x minus 2 equal to 0? X equals 2. X minus 2, for what number subtract 2 from it is going to give me 0? If x is equal to 2, x equals 2 makes x minus 2 equal to 0. If x equals 3, 3 minus 3 equals 0. These two items, x equals 2 and x equals 3, solve the quadratic equation in regard to that. They're being solved by completing the square. There's a number of ways to do these guys. You don't necessarily have to do a particular way. I mean, if you know how to get these done, at the end of the day, people are looking to see, can you solve the mathematics that is presented to you? Okay? So let's see what we can say here. So the answer, as we said, after all of that, was this. And we'll talk more about this in class as we need to do so, or if we need to do so. So if I'm going a little bit fast now, we can always come back and talk more in class about it. 2x squared plus 8x equals 10. To complete the square, there's a lot they do here. I don't know. Can't say I'm not going to do it that way. Let's just do it. They're asking us to do it. Let's do it. So what we have here, you got to add something to this side, and when you do it, you're going to add the same thing to this side. Take half. Don't worry about the x. Just look at the 8. Take half, not the x. Take half of 8, which is 4, and square it. What's 4 squared? 16. If you put a 16 over here, put a 16 over there. There's a little more to this than meets the eye. I should have maybe done this a little differently. Time out on this. I mean, what I just said is true. What I just said is true, but it's not really what we want to be doing. There's probably easier ways to do this than what is being asked of you. Well, let's not even go there right now. 2x squared plus 8x plus potentially something is going to equal 10. Plus potentially something. Take a 2 out of here. Keep an eye on that closely. I didn't do any bad mathematics here, guys. I didn't multiply the quantity and make it bigger on the left-hand side thereby necessitating that I would have to multiply by the exact same quantity. I did not multiply on the left-hand side by a particular quantity where I would be necessitated to have to multiply by the exact same quantity on the right side. Didn't do that. I just did a factorization. Take half of 4, leave it like this. Take half of 4, which is 2, square 2, and you get 4. Take half of the 4, which is 2, square the 2 and get 4. What happened here? Well, 2 times 4 is 8. You didn't add 4 to this side of the equation. You added 4 inside of here, but 2 times 4 is 8. So you added 8. You added 4 in here, but when you multiply by 2, it's 8. You added 8. 8 was not present. There's 8 been added to this that was not initially present. So if you essentially adding 8 to the left side means you got to add 8 to the right-hand side. This right here becomes a perfect square. It becomes x squared, it becomes x plus 2, the quantity squared. X plus 2, the quantity squared, you grind it out, you're going to get this. You have these two, you got 18. Divide by 2 on each side of the equation. Divide by 2 on each side of the equation. You got this. X plus 2, the quantity squared, equals 9. If you square root both sides, it's plus or minus the square root of 9. The square root of this is x plus 2. Here, it's plus or minus the square root of 9, which is 3. If you subtract 2 on each side, that's out of there. You get x equals, add a negative 2 on each side, you get negative 2 plus or minus 3. What does that mean? Negative 2 plus a positive 3 is 1. Negative 2 minus 3 is negative 5. X equals 1. X equals negative 5. I'm not particularly fond of completing the square. It's valid mathematically. It's not my favorite way of proceeding, but it does give some interesting results. So having done that, that was 2. What did you get? Negative 1? Forgive me, 1 and negative 5. So what do we have here? For 1, we got 2 and 3. And for problem number 1, we got 2 and 3. For problem number 2, we got 1 and negative 5. Right. For number 1, we got 2 and 3. For chapter 5, TM2, for number 1, we got 3 and 2 or 2 and 3. And for 2, we got 1 comma negative 5. You got it. You got it. So that's pretty good. Let's keep going. For 3, find by the square root method. There's a number of ways here. There's the quadratic formula for number 4. Let's run through these. Let's get through these guys. Okay, let's keep going. So let's look at 3 and 4 and just proceed. Let me just get through this. 3 by the square root method. There's a number of ways you can go here, actually. If they're giving you this, you got 3r squared equals 81. Divide by 3 on each side. 81 divided by 3 is 27. R squared equals 27. If you square root both sides, plus or minus be the answer. R is here. You got plus or minus the square root of 27. Got a question to ask. Is 27 the same as 9 times 3 or 3 times 9? The root of a product, we've gone into this, the root of a product is the product of the individual roots. The square root of 9 is 3. The square root of 3 is a radical. We're just going to leave it. R equals plus or minus 3 square root of 3. Now, that's technically the most quote-unquote mathematical way to write this. They may be asking here to the nearest hundredth, so we're going to have to, you got two answers here for that. You're going to say, okay, if that's the case, if r is equal to this, r is plus or minus 3 square root of 3. R is equal to 3 square root of 3. R is equal to negative 3 square root of 3 is what it means. Approximately, what does that equal? Not strictly equal. This is equal. This is exact mathematical entity. What I'm about to do here is an approximation, okay? So, actually, don't even call them equal right now. I just set it over here. To the nearest hundredth, what would that be when you're doing that? Well, let's see what we got here, guys. I mean, okay, guys, I just want to make sure that my microphone's working. Okay, it's working. Yeah, I mean 5.1962 roughly. 5.1962. So if you're rounding that, if we're rounding that, 5.1962, 0.1962 roughly, to the nearest hundred, does that go up to a 10, making this whole thing a 20? Yeah, it sure does. Negative 5.20, positive 5.20, if you're going to round it to the nearest hundredth. I cannot emphasize enough, my friends. I cannot emphasize enough that that's a good approximation. The exact answers no approximation at all. The exact answers are this. And you could take it to any degree of accuracy that you wish, actually. Very important. So we did what we did. That was 3. 4, use the quadratic formula. I'd like to show you 2 looks at this, just to kind of show you the power of the mathematics that's involved. And we could kind of take it from there. When they're saying for number 4, if it indeed works, I watch me be wrong on this, but I think this works. You should opt not to do the quadratic formula if there's an easier way to do it. Can you do a factorization here? I think you can. 2x times x, 2x times x is 2x squared. 1 times 3 is going to make it happen. Tell you what I'm going to do. I want a -5. I'm going to use a -3 right here and a +1, and I think I'm in business. I think this is a lot easier than doing the quadratic formula. I am going to do the quadratic formula, and I better get the exact same answer. There's no point of mathematics. There's no point in the mathematics if it's not giving you the same answer if you're doing everything consistently, regardless of methodology that you use. Regardless of how you do what you do, if your mathematics is sound, you should be getting the same exact correct answer that you're getting with any other technique in mathematics. Regardless of technique, if the mathematics is sound, the same right answer is attained every time. If it's not, there's something wrong, and things do get wrong sometimes. You saw me make mistakes here as well. Try to correct them. Well, here's the big thing. The big thing about factorization, guys, is 0 times anything is 0. Anything times 0 is still 0. If they're both 0, yeah, they multiply out to 0. This could be 59 trillion, and this could be 0. 0 times 59 trillion is still 0. If this guy's 0 or if that guy's 0, you're set. In other words, 2x plus 1 could equal 0, or x minus 2 or x minus 3 could equal 0. Well, how would you get this guy to be equal to 0? I'd say 2x plus 1 equals 0. Subtract 1 on each side. 2x equals -1. 2x equals -1. Divide by 2 on each side. X equals -1/2. X minus 3 equals 0. Add 3, forgive me. X minus 3 equals 0. Add 3 on each side. X equals 3. X equals -1/2. X equals 3. X equals -1/2, x equals 3 solves it, period. It's a lot easier than doing the quadratic equation. What I did was factorization. The big thing is, my friends, if they ever tell you, A times B times C times D times E equals 0, either A equals 0 or B equals 0 or C equals 0 or D equals 0 or E equals 0. One of them at least has to equal 0. They could all equal 0, but they don't all have to equal 0. As I said, this could be 99 trillion. This could be 0. Or the E could be 99 trillion. This could be 150 trillion. This could be 2 billion. This could be 5 billion. And that could be 0. If one of them is 0, they all go to 0. If you set each of these, if you set each factor, if you set that factor equal to 0, you got one of the solutions. If you set that factor equal to 0, you got the other one of the solutions. The answers we got were x equals -1/2 and x equals 3. And that's it. You're done. And we did it by using factorization. Always opt to use factorization before you go for the quadratic formula. But, you know, if you need to use the quadratic formula, we will use it, and we're going to use it now. We do know what the answers are. The answers are x equals, notice this is a degree 2 polynomial. According to Gauss, there are going to be two solutions. There are two solutions there. This polynomial right here, 2x squared minus 5x minus 3, right up here, 2x squared minus 5x minus 3 equals 0. You can do it with the quadratic formula, and you better get the exact same correct answers that we just got by using we used factorization, and I thought it was easier to use factorization. X equals negative a half, x equals 3. All right, well, let's see if that's true. Sure hope it is. The mathematics has to be sound. Well, let's hope. Let's see it. Typically, the quadratic equation says ax squared plus bx plus c equals 0, where a, b, and c are constants. ax squared plus bx plus c equals 0, where a, b, and c are constants. Notice everything's written in an additive phenomenon. So when I write ax squared plus bx plus c, everything's in terms of addition. They could be negative numbers, but you got to write it in terms of addition. X is equal to two solutions. The opposite of the b coefficient, this right here, the opposite of the b coefficient, plus or minus the square root of this quantity, b squared minus 4ac, whatever that happens to be. Everything, including the negative b, is divided by 2a. And these are this. This is the quadratic formula. Guaranteed to work. Can be a little tedious sometimes, but it's guaranteed to work. All right, let's see what we got. See what we can say here, guys. X is equal to, well, I mean, I guess we got to make this thing work. I guess in this particular instance, let's line everybody up the way they're supposed to be lined up, I guess, right? Let me take, we know what we're doing. Let me take 2x squared minus 5x minus 3 equals 0. So 2x squared minus 5x minus 3 equals 0. Minus 5x is plus a negative 5x. Minus 3 is plus a negative 3. The a is 2. The b is negative 5. The c is negative 3. You've got to make it look, though, you've got to make it look like everything's being added to be able to apply this formula. If you leave it like that, you're going to have problems. You've got to convert this thing. You know, at the end of the day, you got to say 2x squared minus 5x is plus a negative 5x. Minus 3 plus a negative 3. Okay, that'll work. That'll work. Absolutely, that'll work. When you're looking at it, ax squared plus bx plus c equals 0. The a is the 2. The negative 5 is the b. The a is the 2, the b is the negative 5, the c is the negative 3. All right. What do we say? So we said the b is the negative 5. The b is a negative 5, huh? If the b is a negative 5, you're going the opposite of b. Plus or minus the square root of b squared, which is the quantity negative 5 squared. Negative 5 times negative 5 is going to be positive 25, so watch out. 4 is 4. A is 2. C is negative 3. Everybody, including the negative, the opposite of negative 5, is under 2a. A is what? A is 2. Yeah, it's a mess. It's a little bit of a mess. That's why you're better off. If you can do a factorization, do a factorization. The opposite of negative 5 is 5. The quantity negative 5 squared, that's what it is. You've got to put it in a quantity. When you say b squared, everybody's in a quantity. Even though it doesn't look like it over there, everybody's assumed to be in a quantity. Negative 5 times negative 5 is 25. Here we go. Be careful. Be careful. Leave that minus for now. What's 4 times 2 times negative 3? 4 times 2 is 8, times negative 3 is negative 24. We got to talk about that. 2 times 2 is 4. What is 25 minus a negative 24? Minus a minus is plus. Minus 25 minus a negative 24 minus a negative 24 is plus 24. 24 and 25 is 49. We've got x. X equals, let's go. The opposite of negative 5 is 5. It's 5, okay, so that's cool. 5 plus or minus the square root of 49. Okay, that's a pretty relatively easy square root to get. 4 is 4. 4 is 4. Let's go to the plus scenario, my friends. Cover the minus. Cover the minus and put the plus scenario. 5 plus the square root of 49 over 4. That's one of them. The other one is 5, cover the plus and go minus here. Let's talk. Square root of 49 is 7. 5 plus 7. We'll divide that by 4 and get an answer. 5 minus square root of 49. Square root of 49 is 7. 5 minus 7, we'll get an answer. Then divide by 4. 5 and 7 is 12. 12 divided by 4 is 3. 5 minus 7 is negative 2. Negative 2 divided by 4 is negative 1/2. I'm getting answers of 3 and negative 1/2. We got those answers over here. 3 and negative 1/2. Let me just see, guys. I want to make sure it prints out okay. It shows pretty good. Yeah, it should be. It is visible. Okay, that's a negative 1. Negative 1/2. All right, so same thing. So we got negative 1/2 and 3. We've got negative 1/2 and 3. Sounds good to me. Works. It works. That was 4. 5 and 6. 5. Solve for capital R when you got capital Z squared equals capital R squared plus capital X squared. Okay, let's just knock these out real quick. Okay, let's see what we can say here, guys. Could have sworn I had more chalk, guys, for a second there. All right, well. So for 5, solve for big R. Z squared equals R squared plus X squared. Now it depends how you want to give a final answer on this thing. If you want to solve for R squared, subtract. If you want to solve for R squared, subtract X squared on each side. And you got R squared. R squared is equal to Z squared minus X squared. Square root both sides, you're probably looking for the principal root. If they want to go plus or minus on this, we can go there. Let me just look at how they are reporting the answer. There you go. That was that one. Right, they didn't go plus or they did not go plus or minus with this. They just went with the principal root, and that's fine. That works. So that makes perfect sense, actually. Just look at it. Yeah, that's fine. For problem 6. For problem 6, they're saying that the area of a triangle is 450 square meters. Its base is 25 meters longer than its height. Find the base and height. A lot of ways to go here. Or are there a lot of ways to go? I don't know. It's hard to call it. Here's some kind of a triangle. Here's the height. Here's the base. The area of the triangle is 1/2 base times height. They're telling us the base is 25 meters longer than its height. The base is whatever the height is plus 25. It's 25 meters longer. Its base is 25 meters longer than its height. Find the base and the height. So the base is 25 meters longer than the height. The height is equal to the height, obviously. And if that's the case, area equals 1/2 base, which is this, times height. That's the base, that's the height. They're telling us the area of the triangle is 450. If you multiply by 2 on each side, this becomes 900, and the 1/2 disappears. Right? So if you took this, you multiplied by 2 on each side, 2 times this is 900, 2 times this, break that and get down to here. A lot of ways to go here. Multiply by h all the way across. You get h squared plus 25h equals 900. (900) equals h squared plus 25h. So we can kind of look at that. What is going on with this, you guys? Well, pretty important stuff. What happens is, if you subtract 900 on each side, you get h squared plus 25h h squared plus 25h minus 900 equals 0. Don't know a good way to look at it, other than maybe there's a couple good guesses we can get out here. There's a lot to say. 1 times 900 is 900. 2 times 450 is 900. 3 times 300 is 900. There's a lot to say here, guys, as we said. 4 times 225 is 900. 5 times 180 is 900. It's a lot. So there's a lot going on for our guesses here, guys. We could, kind of look at this thing and say, wait a minute. 1 times 900 is 900. 2 times 450 is 900. 3 times 300 is 900. 4 times 225 is 900. 5 times 180 is 900. 6 times 150 is that. 9 times 100 does it. Yeah, it's quite the deal. You could get 12 times 75 does it. Believe it or not. 12 times 75 will get you there. 15, right? 15 times 60 will get you there. It's a lot. 18 times 50 will get you there. What else? 20 times 45 will get you there. 25 times 36 will get you there. That's something crazy. 30 times 30 will get you there. And I think it just starts reversing itself pretty much. Then it comes back to 25. That's a lot of stuff here, guys. Well, I don't know. I mean, look, I just wrote down a lot of factors here. Are any of them going to add up to 25 when we do some monkey business with this? I got an idea. We kind of lucked out looking at it. You could, this wouldn't be a bad place to use the quadratic formula. You're about to get the same answer that I get when you do it. When you do the quadratic formula here, you are going to get 2 solutions. One of them is a negative answer, which is absurd. Only the positive answer will count. We did say that 20 times 45 is 900. And if you take 45 and subtract 20 from it, you get 25. I got a feeling, if you don't like it, then now do the quadratic formula. This is not a bad place to do a quadratic formula. If you can do a factorization, go for that too. Turns out, now you may not even need to write all these. You might just look at it on your own, just kind of go through it in your mind when you're doing it. But I'll go plus 45 right here, and I'll go minus 20 right here. Is that working? Yeah, it's working. H times H, H squared. Negative 20 times 45, negative 900. Negative 20H and positive 45H is 25h. It's working dead on. H is equal to negative 45 is the solution mathematically, but it's absurd for us. It's not going to work. This, what number plus 45 will give me 0? I want this guy to be 0, or I want that guy to be 0, right? We talked about that already. Well, negative 45 works, and over here, what number minus 20 will give me 0? Jackpot. This is it. This is it. This is what the height is. This is what the height is. This one mathematically works, but not. So what's the height? This is the one that works. The base is the height plus 25. Base is the height plus 25. If the height is 20, 20 plus 25 is 45. The height is this. Do you get 450? Do you get 450? That's the big, that's the big thing on something like this. Yeah, 45 and 20. Is that true? 45, well, this is true right here. 45 times 20 is 900. Half of that is 450. 450 was the area. We started from scratch with the area being 450. Is 45 times 20 900? Sure is. Times a half, that's 450. It works. That's it. So that's what we're looking at. Just checking the audio here, guys. Okay. Yeah, 20 by 45, or 5 by 20. It was 45, the height was 20. Didn't they say the base was going to be 20 more? Forgive me. They said the base was going to be 25 more than the height. Okay, that's all good. Fantastic. Okay, we'll finish the rest very soon. Please utilize these resources, guys. They take forever to put together. I hope they can help you out. There's a lot. Once you know these hundreds of problems, you know a lot of basic algebra that helps you move into other fields, that helps you move into other areas where you can study other matters. It's really strong foundational material. Not because I'm doing it, but because when anybody does it, it's worthwhile. I happen to have the time to look at some of this stuff. Other people also have the same amount of time to do it, and they do much more. Whatever resource you take, if the resources are there, and there should be many resources outside of anything that I'm doing, and hopefully some of what I'm doing, any resources that you wish to look at, please look at it. Probably you get a lot of foundational knowledge, and you're building a strong foundation. It's really going to help you out. Okay, let's go to the final exam review, part D, shortly.